Okay, this is a lesson 11.4, and it's about series. So series is a sum of the terms in a sequence. So for instance, if you happen to have, let's say the sequence 2, 4, 6, 8, then the series would be 20 because all we had to do was add up all those numbers. Now every term in a sequence, depending on the sequence itself, may or may not actually have a sum. So if you had, say, I don't know, 4, 8, 12, 16, where you're going up by 4 each time and it's infinite, then this actually would just keep going to infinity. That's a divergent one. There's no sum. We're going to talk about that more in a little bit more detail in a different lesson. If you happen to have something like, say, the fractions, where you have like 1/3, 1/6, 1/12, 1/24, and so forth, like this, and it was infinite, this actually converges on 1. So that one does have something special, but that's kind of like a little introduction. We're going to talk about the divergent and convergent ones in another lesson. As far as the partial sums, and that's just the sum of a certain number of ones. So sum of, let's say, a specified number of terms, like it is here. Of a sequence. So notice on this first one, they're asking us for the sum of 7 of them. So if I don't have 7, let's see, 1, 2, 3, 4, 5, 6, 7, I need 2 more. So I need to find out what are they doing each time, and if you notice from one to the next, we are adding 4. And that's consistent. They're adding 4 every time. So this is an arithmetic one, and they're adding 4 each time. So if I do the next 2 terms, that would be 22 and 26. So the sum of the 7 ones, I could just take my calculator and add them all up. 2 plus 6 plus 10 plus 14 plus 18 plus 22 plus 26, and you get 98. Okay, so whenever you have ones like that where they're just asking you to sum the so many and they give you the sequence, you can just add them all up. Notice on, let's see, if they just give you a part, like see how these 4 are basically the same. But on number 5, they don't really give the sequence, but they tell us what the sequence is by the formula. So S of 5, if we want the sum of the first 5, we have to find the first 5. So we plug in 1, and that gives us 1 cubed. Then we plug in 2, and we plug in 3, and we plug in 4, and we plug in 5. And then we just add all those things up together, and you get 1 plus 8 plus 27 plus 64 plus 125 is 225. Okay, so all of these are basically the same, where you just plug in the numbers up to the series, the number of terms you need, and just add them all together. Now, one of the nice ways is if they actually use what they call summation notation, which is using the Greek letter sigma to denote the sum. And that's this letter right here. That's a sigma. And it kind of just tells us, hey, this means add up all the terms in the sequence. So the number on the bottom is your first term, tells you where to start. The number on the top is your last term number, so that tells you where to start. And then the actual formula, this piece, is the formula for the sequence. So they're telling you, you're going to plug in n of 1 first into that and get the first term. And you just keep going every number until you get to this one up at the top, and then you just add them all up. That's what it means. So like here, if I plug in 1, we would get 2. If I plug in 2, I would get 4. If I plug in 3, I would get 6. 4, I would get 8, and 5, I get 10. So if I add all those up, you get 30. So the answer to that particular problem is 30. Now the great thing about the summation notation is a lot of times you can just simply plug all this in your calculator. You don't necessarily have to show all those steps. I mean, you can if you want. We can say what it means. Like if I plug in 1 here all the way to 14, if I plug in 1, this would give me 6. If I plug in 2, I would get 7. If I plug in 3, I would get 8, and so forth, all the way to 14. If I plug in 14, I would get 19. So they want the sum of all of these things up. So I can just simply add them all up, or I can use my calculator, and there is a math button. If you go to math and then hit 0, it brings you to the summation notation, and you essentially can plug it in exactly like you see there, and it should give you 175. So all of these that have the summation notation, when you're going from a number to a number, I am happy with you using a calculator on that part. If you need me to show you how to put it in, please ask, and I'll be happy to show you during class or at school. Okay, so the next little part that we're looking at, let's see, if something's in the front, like this piece right here, you got something in the front, that's okay. Just plug it in your calculator first and then do times and then put in the rest of it. So it'll still work it out just fine, not an issue. Okay, so next page. All right, so an arithmetic series is just the sum of an arithmetic sequence. And we did the sequences on the other lesson, the other test, so you should be familiar with the arithmetic sequences. So the formula for this is to find the nth term, or the sum of the first n terms. It's n divided by 2, first term plus the last term. So n is your number of terms. A sub 1 is your first term. And a sub n is the last term. And remember, when we're using the arithmetic sequence, the explicit formula is a sub n is equal to your first term plus d, which is your common difference, n minus 1 times. So you need to know that one. That was from the previous test. But that comes up sometimes in these problems when you're going to solve them. So for instance, on this first one, they're asking us to find the sum of 18, the first 18 terms. Well, I know to find the sum of 18 terms, it would be 18 divided by 2, first term, which is 7, plus the last term. But notice we don't know what the last term is. They didn't give us the last term. So we have to go to the side and say, you know what? We know how to find the 18th term because we just did this on the last test. It would be the first term plus d. Let's see, d in this case is 3 because they're adding 3 each time, notice. So that would be n minus 1 times, so that would be 17 times. And then I can just find out that the last term is 58. So I'm going to put a 58 here inside my problem and then just solve that, and you should get 585. So anytime you're looking for the last term, you're going back to what you learned from the last test and say, oh yeah, I know how to get the last term. Voila, there it is. So all of these basically are the same, those 4. Now when you hit number 5, notice on this one, it has, I thought I was on highlighter. It has it in sigma notation. So you simply can just plug that in your calculator. I am totally okay with that. And if you do, you should get 340. If you want to do the formula and do it like number 1 up there, you certainly can do that too. Not a problem. Either way is fine with me. Okay, so notice 7 through 10 is basically the same. I do want to point out, though, that sometimes that bottom number is not 1, so don't always assume it's 1. Notice this one's going from 4 to 17. So you're just, doing the ones that they're telling you there. But if you plug that straight in your calculator, you'll be fine. All right, so here is the hard part, the application problems. And they're all kind of different, but yet kind of the same. Like you have to figure out which formula you're going to use. Now the great thing about this one is since it's all arithmetic, I believe these are all arithmetic, but you're looking for different things different times. So you're using the same formula, but you may be looking for a different value. So on number 11, they're training for a marathon. They tell us that she ran 2.4, then 2.55, and then 2.7, and so forth, okay? And they want to know the total distance. That word generally means you're finding a sum. Occasionally they throw that in and you're not finding the sum, which makes it a little bit more complicated. But more often than not, if you see the word total in there, you are grinding the sum. So the sum of, let's see, 60 days. So the sum of 60 would be 60 divided by 2. First term, which is 2.4. But then I need the last term. So just like before, we've got to go over there and figure out, well, what is the last term? Let's see. The 60th term would be the first term plus, let's see, what are they doing each time? You have to subtract it out if you don't see it already. They are adding 0.15 each time. So this would be 59 times because it's one less. And that gives us 1125. Okay, so I got to put 1125 into that. And then I can plug all this in your calculator. 30 times 13.65. And we get 409.5 miles. So a lot of times when we're just looking for the sum, it's pretty straightforward, kind of like what we did already. This one, however, on number 12, it ups the ante a little bit. We do have to find the sum, but notice they want us to find the number of tickets left after the first 2 hours. So I know if the maximum is 75,000 people, I got 75,000 minus ever how many were sold in that first 2 hours. So that's going to give me my answer. So let's see. They have, oh, it's this thing here. So in the first minute they sold 35. And then every minute more they're selling more. Looks like they are adding 8 each time, right? So our common difference is 8. Okay, so I need the sum of the first, let's see, 2 hours would be 120 minutes. So that would be 120 divided by 2 of first term plus the last term. Okay, they didn't give us the last term, so we got to find the last term. So I'm going to go over here and find the last term. So the last term, a sub 120, the last term would be the first term plus 8, 119 times. What does that come up to be? 987, I think. Okay, so 987 has to go here. And then that sum is 61320. Now, that's not the answer to our question. That's how many tickets were sold in the first 2 hours. To see how many are left, then I got to subtract that from the 75,000. What does that give us? 13,680 tickets left. So you got to be careful that you're actually answering the question that they're asking. All right, so number 13 is a little bit more challenging because they are telling us the sum of how many bricks were used, but now we have to find out n, basically, the number of rows. So I'm still going to use that formula. The sum of n number of rows would be n over 2 first term plus last term, okay? That's our formula. How many bricks were used? 3, 1, 1, 6. Okay, how many rows it is? We don't know, so we have to leave it as n. First term, that was 200, plus the last term. Well, that's a little tricky because we don't know how many rows it is, but we do know that each one has 4 fewer bricks than the row beneath it. Okay, so I'm going to go over here, and I know that nth term is the first term minus 4 n minus 1 times. That's what we know about it. So that's the last term. We're going to say that's our last term. We're going to plot it right here. This would be 200 minus 4n plus 4. All right, so there's our last term. Now I've got one equation with one variable. I can solve this. It looks a little gross, but I can certainly solve it. Let's see, what are we going to do first? I can add those things together. So 3116 is equal to n over 2. This would be 400 plus 4, so 404 plus, no, minus, 404 minus 4n. All right, so now I'm going to distribute right here. So 3116, this would be 202n minus 2n squared. So now I see I got n squared, n, and a constant, so I know I need to put them all on the same side, make it equal to 0 to be able to solve this. All right, let's see, I can factor out a 2. That should help at least a little bit. Oh, what is half of 3116? 1558, I think. Okay, so if this one factors, which this one actually does because I played with the numbers to make sure it would, but if it doesn't, you can use your quadratic formula to go straight to the answer here. But I happen to know that this factors to n minus 19 and n minus 82. So n is either 19 or n is 82. But this one ends up being an extraneous, because if I plug that in, it's not gonna work. Like if I plug in of that n of 82, it's too big. It won't work. But 19 does. So, how many row is it tall? It's 19 rows tall. So notice how we're using the same formula, but we're solving for something different. Now I know this one is part of the homework, but since someone asked about it, I'll go ahead and talk about this one. It's very similar to the one we did, the last one from the notes, number 13. The Jefferson Theater contains 2,800 seats. If the first row has 12 seats and each row after that has 4 additional seats, determine the number of rows. All right, so basically that's very, very similar. So it is the sum, 2,800 is the sum of all those things. So we know 2,800 would be equal to n over 2. Let's see, first term, 12. Last term, again, that's where you've got to go figure out what was the last term. Well, the last term would be the first term plus 4n minus 1 times. That's your last term. And then now we just solve this equation. So it can get a little yucky, but we're going to do this. Let's see, how can we do this? Let's see, this would be 2,800 equal to n over 2, 12 plus 12, and then of course that would be minus 4. So 24 minus 4 is 20 plus 4n, and if I distribute that, that would be 10n plus 2n squared. If I set it equal to 0 and solve, ooh, I can factor out a 2. So, will it let me write down here? Oh, it does. Good. Yay. If I factor out a 2, this is n squared plus 5n minus, what does it come up to be? 1,400? Yeah. Okay, and let's see. Will this factor? Yeah, I think this does factor. This would be n minus 35 and n plus 40. So n, it has to be the 35, or n is negative 40, and we know it can't be negative, so 35 rows is our answer.